This video discusses the detector arm circuit in a Beogram 4000 series turntable. I will discuss the circuit diagram, and I will show how to convert the light bulb in the sensor arm to an LED. For more information, please visit my blog at beolover.blogspot.com or go to my website at www.beolover.com. This shows all the actors in play that allow to determine whether the pickup can be lowered onto the platter or not. First, we have the detector arm, which has a light source. Originally, this is an incandescent light bulb. Here you already see it replaced with a white LED. And there's also a photocell in this arm that detects the reflected light from the platter. So depending on whether the reflection is pulsating or not, the electronic circuit determines whether there is a record on the platter or not, and that then is a necessary condition for lowering the pickup. Down here we see the position slide, and you see here these black markings, and two of the black markings, these narrow ones, this one and the other one is right here underneath the platter at this point, they serve to detect whether it is a 33 RPM or a 45 RPM single record. Only if one of these position markers is detected together with the presence of a record, then the electronic circuit allows the lowering of the pickup. Okay, let's observe this in action. So I'm going to press start now, and then you'll see how the sensor tells the electronics to not lower the pickup, and then approximately at this location, when the possibility occurs that there might be a single on the platter, then the speed switch occurs, and then at the end we'll hear the end switch click that then sends everything back. There was the speed switch, and this was the end switch. This here shows the relevant section of the circuit diagram for the detector arm circuit. There are two necessary conditions that need to be met that the tone arm can be lowered. One condition is that one of the position markers is detected. This causes TR7 to turn on. The other condition is that we have 15.5 volts at this point, and so the 15.5 volts are being controlled by the signal on the photocell in the detector arm. Now the photocell is over here, OPH1 or 0pH1. So if we have light impinging on the photocell, then this photocell generates a voltage up to a few hundred millivolts depending on the intensity of the light. If this light is pulsating, then we get a alternating voltage across the photocell, which can then be transmitted through this capacitor and trigger TR3. So TR3 starts turning on periodically, which gives us a signal at its collector, and this signal then turns on TR4 periodically, and so we get the 21 volt rail up here connected to the capacitor, which leads to a voltage build up, and so the base of TR6 is not being pulled down. The base is pulled up here anyway from this 9 volt point up here, but as long as we don't pull here towards ground, the transistor is on. And if the transistor is on, then of course the 15.5 volts cannot exist here because we have a near short circuit to ground. So if there is a record present, then we don't get the pulsating signal. These transistors are permanently off, and that means that the base here now is connected via R33 to ground, and that is enough current to counteract the pull up to that 9 volt point here. Note that there is a fairly large resistor, and so this then turns TR6 off, and we get our 15.5 volts up here via R33 from the 21 volt rail. This here shows the relevant part of the circuit that controls the light bulb in the detector arm. So the light bulb is controlled with TR5, that is configured as an emitter follower, controlled by the Zener diode D16 that puts 6.25 volts at the base of TR5, and if you take into account the PN drop, then you get about 5.5 volts that drive the light bulb. The current is provided from the 21 volt power rail up here through R36. So one big concern of this circuit is, of course, what happens if the light bulb burns out. If the light bulb burns out, then the detector arm circuit here comes to the conclusion that there is a record on the platter no matter what, because we simply don't have a pulsating signal on the photocell anymore, which keeps TR4 permanently off, and that means we have the pull down condition for TR6, which gives us the 15.5 volts. So the designers of this circuit had this in mind, and they use the 9 volt point here at the bottom of R36 to provide the voltage for pulling up TR6. So imagine if the light bulb burns out, that drops the current to 0 or to near 0 in R36. So we get a very small voltage drop up here, which increases the 9 volts to a voltage that is pretty close to the power rail up here. So this high voltage, the 20 to 21 volts up here, they are strong enough to pull the base of TR6 high, no matter what we do here in this pull down part of the circuit. So that ensures that if the light bulb is out and no record is on the platter, that if somebody accidentally would press start, that the expensive Soundsmith cartridge that we would have on this tone arm would not get obliterated by the ripped surface of the platter. Not a pretty thought. Now, if we replace the light bulb with an LED, then we drop the current from about 44 milliamps that this light bulb is pulling to maybe 20 milliamps, depending on what LED we have. No matter what, it will be lower probably than the light bulb. And so that causes this 9 volt point to be somewhere between 9 volts and 21 volts, depending on the current that the LED is pulling. So in my case, I put a 20 milliamp LED in there, and that yielded here about 15 to 16 volts, and that is already a high enough voltage to ever prevent that TR6 is being pulled down. So the result was, after I put in the LED here with the 220 ohm resistor, that the detector arm circuit would always conclude that there is no record on the platter, and so the tone arm wouldn't lower anymore. So the solution for this was to replace R36 with a resistor that is about twice the size, to increase the voltage drop again, that we're close to 9 volt. In my point, a resistor of 570 ohm was perfect, and after putting it in, the circuit worked properly again. This here shows what I found after I opened up the detector arm light bulb compartment. The previous owner obviously had made an unprofessional repair attempt, and so what I found was a completely burned out light bulb. The photosensor was flipped backwards, so normally it sticks in here, we'll see that in a second. And then also two of the wires that are supposed to be connected to this little circuit board here were ripped off and actually stuck all the way in the detector arm. So I had to use some long tweezer to extract them. This here shows the sensor arm compartment of my Beogram 4004. I opened it up to have a look how it's supposed to look. And so you see here the light bulb, and you see also that the photocell is actually here in this compartment. And you also see the wires connected. So this here told me how everything is hooked up, and then I went back to the 4002 and started fixing it. Here you see the completed repair. This is the LED. I connected it with the original leads of the light bulb because the gaps between the bulb compartment and the photocell compartments, they are very narrow, I think, to prevent light from going over here. This here is the photocell back in its original position, and then you see here the 220 ohm resistor that I inserted between ground and the negative end of the LED. I also inserted two small pieces of thin cardboard left and right to the LED to hold it in place. In fact, it is very important that the LED be installed in a position that the lens down here is correctly positioned underneath the LED bulb. If that's not the case, then the light that's being emitted is not focused into the right spot, and so the photocell over here doesn't get hit by the right amount of light. I also put a couple of cardboard pieces on top. They serve the purpose to push the LED down, that it sits right on top of the lens. It also prevents, of course, accidental contact between the leads here and the metallic housing of the detector arm. After putting the cardboard in, I gently pushed the compartment back into the detector arm, and here you see it in action, back in business. The only way to detect that there is a white LED in there is, of course, to look at the reflection. That looks decidedly brighter and whiter than the original light bulb that is fitted into this detector arm. If this is something that one wouldn't want, one could, of course, also put a amber LED in there. When I did it, I simply didn't have a small enough amber LED, so I used a white 3mm LED that I had lying around. We're nearly at the end of this video, but I wanted to show you the main PCB of the turntable before and after recapping, and also exchange of resistor R36. This here is the resistor. So if you want to recap this board, you need to replace all the red tantalum caps and here these standard aluminum electrolytic caps. Here's the board with new capacitors and the 560 ohm resistor. This is the resistor after replacement, and you see here those modern 105 centigrade electrolytic caps. This concludes my video about the detector arm circuit in a Beogram 4000 series turntable. Thanks for watching.